The laws of physics feel untouchable, fixed, eternal. You grow up believing they are the ultimate rules of reality, written into the universe itself, governing everything from falling objects to exploding stars. They feel like the bedrock beneath existence, the final authority that nothing can escape. But physics itself is beginning to suggest something far more unsettling. The laws you trust may not be fundamental at all. They may be temporary, emergent, conditional. And if that is true, then everything you assume about reality rests on something far less solid than you think. This discomfort starts with a simple observation. Throughout the history of science, laws that once seemed absolute were later revealed to be approximations. Newton's laws felt universal until relativity showed they break down at high speeds and strong gravity. Classical physics felt complete until quantum mechanics exposed its limits at small scales. Each time, what we called laws turned out to be patterns that hold only under certain conditions. Physics has never reached a final layer where the rules stop changing, and that history matters because it hints that the laws we rely on today may also be provisional. Modern physics increasingly treats laws not as commands imposed on reality, but as descriptions of how systems behave given certain constraints. When those constraints change, the behavior changes. The laws are not violated, they are replaced. This idea is already familiar in condensed matter physics. The laws governing fluids, solids, and superconductors emerge from the collective behavior of particles. They are real, precise, and predictive, but they are not fundamental. They disappear when the underlying conditions disappear. Water has laws, ice has laws, plasma has laws. None of them exist independently of the states that support them. Physics is now asking whether the same is true at the deepest level. The universe itself may be in a particular phase, governed by effective laws that emerge from something deeper. If that is the case, then what you call the laws of physics are more like habits than commandments, stable for now, reliable within a domain, but not guaranteed forever. This idea becomes unavoidable when you look at the early universe. In the moments after the Big Bang, the universe underwent a series of phase transitions. Forces that are distinct today were once unified. Symmetries that are broken now were once intact. The laws governing particles changed as the universe cooled, masses appeared, forces separated, the rules evolved. The universe did not obey the same laws at all times. The laws themselves have a history, and if they have a history, they are not fundamental in the timeless sense. They are contingent on the state of the universe. This realization quietly undermines the idea of laws as eternal truths. Instead, it paints them as emergent regularities tied to specific conditions. Go deeper, and the picture becomes even stranger. In many approaches to quantum gravity, space-time itself is not fundamental. It emerges from more basic entities, networks, relations, information. If space-time is emergent, then the laws that govern motion within space-time cannot be fundamental either. They describe behavior within a framework that itself arises from deeper processes. The laws are downstream. They are consequences, not causes. This flips the usual hierarchy. We tend to think laws produce reality. Physics increasingly suggests reality produces laws. Patterns stabilize, regularities appear, and we codify them as laws. This does not make them arbitrary. It makes them conditional. They are as real as the conditions that support them, but remove those conditions and the laws dissolve. This challenges a deep psychological need. Humans crave fixed rules. We want the universe to be governed by immutable principles. It makes reality feel intelligible and safe. Emergent laws feel threatening because they imply fragility. If the laws depend on conditions, then stability is not guaranteed by necessity. It is maintained by balance, and balance can be lost. This does not mean the universe is about to change its rules. It means that rule change is not forbidden in principle. Physics does not promise permanence. It promises consistency within a phase. The laws you experience are the laws of this phase of the universe. They work because the universe is in a state that supports them. This perspective reframes what explanation means. Traditionally, physics seeks deeper laws to explain surface laws. But if laws emerge, explanation bottoms out not in laws, but in structures, in processes, in relationships. The deepest description of reality may not be a set of equations, but a description of how regularities arise and stabilize. Laws become secondary. They are summaries of behavior, not prescriptions. This idea appears again in statistical mechanics. Temperature, pressure, and entropy obey precise laws. Yet they are not fundamental quantities. They emerge from large numbers of particles interacting. No single particle has a temperature. Temperature is a collective property. The laws of thermodynamics are exact, but they are not fundamental. They depend on scale and organization. Physics now suspects that space-time geometry, quantum fields, and even causality may behave the same way. They may be collective phenomena arising from deeper, non-geometric processes. If that is true, then asking for the ultimate laws may be the wrong question. There may be no final rulebook, only layers of effective descriptions, each valid within its domain. This does not make physics weaker, it makes it more honest. It admits that explanation may not converge to a single set of timeless principles. Instead, it may converge to a framework that explains how principles emerge, persist, and fail. This has unsettling consequences. It means that reality is not anchored by necessity alone. It is anchored by stability, and stability can be contingent. The universe you inhabit may be robust, but it is not logically inevitable. Its laws could have been different. They may have been different in the past, and under extreme conditions they may be different again. You would not experience this as a dramatic violation. You would experience it as a different reality, with different regularities. Just as early universe physics did not feel wrong to the universe that existed then, it simply was. This perspective also changes how you think about prediction. Predictions work because the laws are stable. But stability does not imply fundamentality. A bridge can be stable without being eternal. The laws of physics may be like that bridge, incredibly reliable, incredibly precise, and still dependent on deeper supports you never see. If those supports were altered, the laws would not be broken. They would be replaced. The idea that laws are emergent also reframes the search for a theory of everything. If there is no final set of fundamental laws, then a theory of everything may not list rules. It may describe mechanisms. It may explain why certain patterns appear inevitable given certain conditions, without claiming that those patterns must exist in all possible realities. This is a humbling shift. It removes the idea that physics will one day reveal the ultimate script of the universe. Instead, physics may reveal why scripts appear at all. This brings us back to the title. If the laws of physics are not fundamental, everything changes. Not because the universe becomes chaotic, but because explanation itself changes. Certainty becomes conditional. Stability becomes historical. Reality becomes something that maintains its form, rather than something that obeys timeless commands. You are living inside a regime where the laws work extraordinarily well. That does not mean they are written into the fabric of existence forever. It means the fabric currently supports them. And the deepest lesson physics is offering is not that the laws are fragile, but that they are contextual. They arise, they persist, and under the right conditions, they fade. This does not diminish their power. It reveals their nature. The universe is not ruled by laws in the way a machine is ruled by instructions. It is shaped by structures that give rise to regularities, and those regularities are what you call laws. Once you see this, the question, what are the laws of physics, quietly transforms into a deeper one. Why does reality settle into law-like behavior at all? And why does that behavior last long enough for minds like yours to notice it? Physics does not yet know the answer, but it knows enough to abandon the idea that laws are the final layer. They are part of the story, not the ending. This is Veritas Labs, where truth is tested.